Hello everyone. Today we're going to be looking at the trapezoidal rule and how we can use that to estimate the area under a curve. Alright, so the formula for the trapezoidal rule is this thing here. It looks like a pretty big formula, but when we break it down, it's actually quite simple. So let's just go through a practice question and then we can see how to use it. Okay, alright, so let's say we're asked to approximate the area under the curve for the graph x squared from 0 to 4. Okay. Now, the way the trapezoidal rule works is if we do a diagram here, so do it down here. So x squared is this shape here, right? So we're asked to find the area of the curve under the curve from 0 to 4. So 0 is here, and we might have 1, 2, 3, 4. It's not the best drawing, but we can change it to make it a bit better. So let's say that this goes all the way up this way. Okay, so the trapezoidal rule, it works because it approximates the area under the curve as a series of trapeziums rather than rectangles. So in the other video, we looked at rectangles under the curve, but it actually is trapeziums now, and that's a lot better to approximate. So what it basically does is it draws a series of trapeziums under the curve to kind of estimate the area. All right, so there would be another little trapezium here as well. So we have to start off with, we have to actually have a value for the number of trapeziums that we're drawing. So the question will typically tell you the number of parts or the number of trapeziums that you are to use to estimate the area under the curve. So this question might say use n equals 4, which means we have 4 trapeziums. So we can count them. We've got a trapezium from 0 to 1 there, 1 to 2, and then 2 to 3, and 3 to 4. So that gives us 4 trapeziums. So we have n equals 4. N is the number of trapeziums. Alright, so that's kind of the mathematical reasoning of what we're doing. Now let's actually work through the formula. First thing we need to do is find this W value. So the W is here. Now W equals B minus A over N. So in the formula, B is our upper bound, A is our lower bound, and we're told that N equals 4. So we can sub that in. We've got 4 minus 0 over 4. We get W is equal to 1. So W is 1. So we looked at before our different X values, where our trapeziums will be between. Then we had our X values were 0, 1, 2, 3, and 4. Okay, so we actually label this as x0, x1, x2, x3, and x4. So there are 4 values there. Now, we have to evaluate f of x for these different x values. So the next step, we do f of 0. So we're subbing in x0 now. We're subbing in x0 into our original function. So if we do that, we sub in x is equal to 0. So 0 squared is just 0. So f0 equals 0. Now f1 equals 1. f of 2, so we do 2 squared, which is 4. F of 3, 3 squared, 9. F of 4, 4 squared is 16. So these are our f of x values for our different x1, x2, x3, x4, and x0. So now we have these numbers, f0, f1, f2, f3, f4. We can sub them into our formula up here. That's the next step. All right, so this is our formula here. All right, let's break through how we sub that in. So f0 and f4 are the start and the beginning values. They're kind of the ends. Okay, so remember when we did the diagram before, 0 and 4 was the beginning and the end of the trapeziums. So the upper and lower bound. Okay, so we put f of 0, which is here at the start, and we put f of 4. Now when we sub 4 into here, which is what we did before, then we get f of 4, which is 16. F of 4 goes here. So the two ends, end value, they go at the end of, at the outside of the formula. Okay, now everything in between, those middle values, are the f of 1, f of 2, f of 3. So everything that is in the middle is multiplied by 2, which is what this is saying here. So if we look up the top, 2 times f of x1, f of x2, f of x3, and there can be more as well if you have a higher number for n. So that's our formula there. And we sub that in, and then we get this formula down the bottom. Now we can go ahead and simplify and solve that. All right, so if we simplify that expression, then we get 22 as our final estimate for the area. So remember that it is an estimate. So in our final answer, we have to indicate that here. So the area from 0 to 4 under the curve of x squared is approximately 22 units squared. And you can check that by finding the actual area using a calculator and see if it's the same or close to the same. All right, hopefully that makes a bit of sense.